So guys, we continue with our thyroid hormone synthesis. So, so we said that the thyroid has got spherical structures called follicles, and these structures, they are lined with a single layer of follicular cells or thyroid cells, right? So, and we said that inside of those cells there is what is called a colloid inside there. And so we said we're gonna take 3 cells and zoom to see how are these thyroid hormone actually produced. So this is just a recap, guys. We have spoken about this already. So those are the 3 cells that we're gonna be using to demonstrate. So this is the apical membrane, this side. This is the basolateral. So the basolateral membrane is the one that has got a capillary or a blood vessel. And on the previous video we did say that when we eat food that has got iodine in the GIT will be converted to iodide. So here is our iodide, or here is our iodide ions in the blood. Now we need to get this iodide into the cell. So the guy that helps us with that is the symporter. The name of the symporter is sodium iodide symporter. So this symporter will make it possible for the iodide ions to enter the cell. And we did say that this involves ATP because it's moving the iodide ions against their concentration gradient. And we did say that TSH plays a huge role in the upregulation of these sodium iodide symporter membranes, right? Now, and also getting the iodide across to the apical membrane, the TSH plays a huge role there as well. For the iodide to be able to exit out into the colloid, we are helped by a guy called it's also another transmembrane transporter or transmembrane protease called chloride iodide transporter. Now we have managed to take our iodide ions from the circulation into the colloid, right? So the first step in thyroid hormone synthesis is to get the iodide into the cells, and that's called iodide trapping. That's the first one. The second one is oxidation. Remember redox reactions back in the day. So what's going to happen here is that iodide ions are going to be converted to iodine, and this job is done by an enzyme called thyroid peroxidase, TPO. Very important enzyme. very important enzyme, TPO. As long as the iodide ions remain charged like this, they cannot be incorporated in the thyroglobulin. So it needs to be an entire atom that is not charged for it to be able to be incorporated. Okay, let's leave that and quickly come here. One thing that we need to know that is there are other things that are happening inside of these cells. So not everything is in sequence. So while all of that is happening, the thyroid cells again, remember inside the cell there are organelles, the nucleus and your rough endoplasmic reticulum and the Golgi apparatus. So the rough ER, as we know, it's a site of protein synthesis. So there's a protein that is produced here, and this protein is called thyroglobulin. This protein, this thyroglobulin protein is very important for the synthesis. It also plays a huge role in the synthesis of these hormones, right? So this thyroglobulin protein is gonna be produced or synthesized by the rough ER or the rough endoplasmic reticulum, and then it's gonna be taken to the Golgi apparatus, and it's gonna be packaged into vesicles, and exocytosis is gonna take place, releasing this thyroglobulin. So I'm gonna draw this thyroglobulin like that. That's our thyroglobulin, right? Millions of them are being produced. So they are sitting and waiting for the iodine there. So the second step is going to be organification. Organification is the incorporation of the iodine ions onto the tyrosine residue. Remember, a thyroglobulin is a protein, and we know that proteins, the building blocks of proteins are amino acids. Now, in this thyroglobulin molecule, there's a special amino acid called tyrosine. A special amino acid called tyrosine. So the tyrosine residue is called a tyrosine residue. It allows them. So the only site that iodide binds to in that thyroglobulin molecule is the tyrosine residue. So now an iodide will come and attach itself there. Actually, this is done by that enzyme once again, the TPO enzyme, right? So now we've got our iodine there, right? Just like that, and that's called here the organification, right? Now, on a thyroglobulin, if one iodine attaches, that will be called a mono iodo tyrosine, or MIT in short. MIT in short. If two iodine molecules manage to bind on two locations on that thyroglobulin, then we're gonna get a DIT, diiodotyrosine, right? So what's gonna happen, the next step will be what is called coupling. Number 4, coupling. Coupling is a process whereby and a DIT combines with another DIT to form basically T4. If an MIT is coupled with a DIT, we get T3. So this is how our enzymes are produced, right? Now, this complex is gonna enter the actually not this complex but this complex with remember there is also the thyroglobulin molecules there as well. So this complex is gonna be endocytosed, so it's gonna enter the apical side or the apical membrane. It's gonna be endocytosed, right? As it enters here, there are a couple of things that are special that happens there. One of them is, remember, we've got lysosomes in a cell. So the lysosomes will split this, releasing T3 and T4 and the thyroglobulin. The T3 and the T4 let me just draw it here. So there's gonna be, so the lysosomes are gonna do what is called proteolysis. So they'll break that complex down, releasing T3 and T4 and also releasing the thyroglobulin. The thyroglobulin is gonna go back and be reused in the second round, while the T3 and the T4 will enter the blood circulation. T3 and T4